few days ago, Abom 79, everybody knows him of course, posted a video where he shows us his work on the straight edges with the shaper. And then one moment he has a little screw up because of the clapper box was in the wrong angle. Now, first of all, I want everyone to know that Adam is one of my all-time heroes, machining heroes. He's one of my favorites. So there's no way I'm gonna criticize him. That's out of the question. Now, the part of the video we're interested in is, I check on my paper, between 9:40 and 12:30. There's a link in the description, and so if you want to check this video out, I think it's a good idea to re-watch the video because it's really interesting work. As always with Adam, he's always really interesting. I'm absolutely not pretending being better or more smart than anybody else, but this video, in fact, I want to add some explications because I see all over YouTube shaper videos and sometimes you see people doing it wrong, and in fact it's not that complicated. I recreated the same situation as in Adam's video. This is straight edge with a bit imagination. You can see it. This is the top surface, of course, and here you can hardly see it, but I made a 45 degrees. Now let's start with the beginning, the angle of the clapper box, this side or that side. To begin, we will start with the most common situation. We're gonna work this surface horizontal. So of course, at that moment we put the clapper system and all this down feed system 0 degrees. Move the part. Ready to cut. Now if we cut, we start on this side and the tool will cut in that direction. Means that after a few cuts we will have this situation, the surface, the cut and the finished surface. The tool must move backwards, of course, and sideways. If the face of the clapper looks at the cut surface, this side, you're in the right way, because now you can hardly see it, but the tool is moving backwards and moving sideways. Now to cut this surface, we're gonna move the tool from the top to the bottom, which means this will be our cut. So the tool has to move, of course, backwards, but also that way. Now if you're not sure that the clapper is in the right way, there's an easy little trick. I have a piece of shim. You can use paper or sheet metal or whatever. Then of course now my fingers are in the way so you can see. I hope this is a bit better. Now the shim is stuck between the tool and the part. So if we move the clapper backwards, shim falls out, which means we have the clearance we need. You can even see the difference. Now we have maybe 0.5 millimeter and now we have 2 millimeter. I hope until now this was convenient and not too complicated, but I don't think so. I think it is really simple. The trick is if you could put a couple of eyes here, and then you think that the eyes always have to look at the cut. Easy, convenient. Now, as you have noticed, I suppose, the clapper did not change angle. So first I was telling about the horizontal surface, clapper was this way. Vertical surface, clapper was the same way. Because we cut in the same way, this 45 degrees is also in the same way. So all we have to do is put here 45, and the clapper is in the right angle. The eyes will look at the cut. Okay, the cut is below here, but I will set it up and I will prove it's right. Of course, on Adam's machine, this 45 degrees was more from this corner to down here, but I suppose you got the point. And to prove that the clapper is indeed in the right way, we will use our shim again. Squeezed, fall out. I hope that was convenient. Let's take a cut. If you make cuts, and especially in an angle, before start always turn the machine by hand at least a full stroke to make sure not to crash into something, because this tool holder system here can crash in the dovetails. It's possible. So of course it's your machine, you do whatever you want with it, but beware, it's possible to break it. Now I'm gonna use these rubber bands because, let me show you. See, small machine and the tool lift is lifting itself. That will do. Still lifting a little bit, but I suppose you got the point. What I miss the most on this machine is an automatic down feed. I'm feeding by hand, kind of manual labor. .45 degrees and still alive. In Adam's video you can see that on the backstroke this tool is dragging on this cut surface. Here you see that's a lot of free space. I don't have this problem, and I think I know what happened, but I'm not sure. Let me explain on the blackboard. I made here a high quality sketch of the clapper system on the shaper. Here of course is the ram, the clapper box with the clapper inside, we can see it. The ram is moving that way, the cutting stroke. And here comes the cutting tool in the tool holder, same as this one. Now, this kind of tool holders, you can put the tool on this side and cut that way, or flip it over. Now you're going to say, what's the difference? Take a piece of chalk. The cutting tool comes here, yeah? Something like that. And you see that this is the pivot point of the clapper. we're gonna throw some kind of straight line through it. This is a straight line. If now the clapper moves up on the backstroke, the tool is lifting. Yeah, that's not complicated. We're gonna put the tool on the other side of this pivot point, right here somewhere. So what's happening is that before the tool starts to lift, first it goes down. I'm gonna exaggerate a bit. The tool is here. The clapper box is gonna lift that way. So first the tool is going down and then it goes up. So if you install a tool in the tool holder, always make sure you are in front of this pivot point, line, center thing, I don't know how to call it. So this one, not good, maximum here somewhere. Of course, I forgot to say, if the tool goes down before it goes up, this is the part we're cutting. The point of the cutting tool will dig in the workpiece. I'm not telling the problem Adam had on his machine is because of the tool was behind the pivot point of the clapper, or maybe the clapper had not enough angle in it. It's a bit hard to see in his video, but of course that's not the point of his video. He's making a straight edge. If you see the cutting surface, there's not even one ding in it, nothing. So it means the clapper box was in the right position. Oh, and Adam, if you're watching this video, you're one of my heroes. To conclude, maybe two little points. First of all, I hope I didn't offend anyone, because it was just an addendum at the Adam's video, and I hope everybody appreciated it. If not, if you did, leave a comment. And point number two, I also hope that someone one day will make a video about this topic and can explain way better than I did. I'm not a teacher, but I do what I can.